Today I want us to look at electricity, and we are going to look at calculation. We are going to look at calculations in electricity. I'll call them resistor calculations. Resistor calculations. Resistor calculations. I appreciate that you have been home for quite a long time, but I have been, of course, engaging a good number of you, and I wish to continue to engage you in this kind of thing. We need to recall a few formulae. Recall that for resistors in series with effective resistance R, we use R1 plus R2 plus R3 if there are three of them. And the diagram for this kind of arrangement will be, if we have three resistors, R1 plus R2 plus R3, we are saying the effective formula would be, to get there, effective would be that. Now, we can take an example that if I have resistors, three of them, and the drawing is like this. And the drawing is like this: 1 ohm, 2 ohm, 3 ohm. My effective resistance, the effective resistance, which I can call R, will be obtained by adding these three different values. And therefore my R will simply be 1 plus 2 plus 3, which will give us 4. And you should not forget the symbol for resistance is an ohm. The symbol is an ohm. You can have another where they say find the effective resistance, or find the total resistance of 2 ohms and 3 ohms. If there are only 2, the effective will be obtained by adding those two values, and this effective will therefore be equivalent to 3 plus 2, which will give us 5 ohms. We can look at the parallel arrangement. We can look at the parallel arrangement for resistors in parallel. The arrangement, for example, if there are 3, can be drawn as this. If there are 3, the arrangement could simply be drawn as that, with the values attached as R1, R2, and R3. And the effective expression, the effective expression for resistance, which we can use as R, will be expressed as 1 out of R1 plus 1 out of R2 plus 1 out of R3. That is for the parallel arrangement. But we have a special case. We have a special case here where we have 2 resistors. For 2 resistors, the special case is that 1 out of R will be obtained as 1 out of R1 plus 1 out of R2. And this is further looked at to give us an LCM here of R1, R2, which we divide through here to get R2, and we divide through here to get R1. And therefore, if we cross multiply R into the sum, will be equal to 1 times the product. And therefore, the R, if you make it to the subject, will be R1, R2 out of R1 plus R2, which we prefer to write as product over sum. Product of resistors over the sum of resistors. So we are saying in a special way, for two resistors that are in parallel, the effective will be product over sum. The effective will be product over sum. For example, we can take an example. Find the effective resistance. The effective resistance. Find the effective resistance. And case A, they give us of 1 ohm, 2 ohm, and 3 ohm in parallel, all in parallel. If they are all in parallel, we have said we use 1 over R will be equal to 1 over 1 plus 1 over 2 plus 1 over 3. And we shall take this mathematically. We find the LCM, which is going to be 6. 6 divided by 1 is 6, divided by 2 is 3, divided by 3 is 2. So we shall get 6 by cross multiplying. We shall get 6 times 1 being equal to R into 6 plus 5. And this implies that our R will actually be 6 out of 11, and you should not forget to put the unit. Part B, if you have a diagram like this, two resistors of the same resistance, for example, 4 ohms and 4 ohms. Since they are two, we use the special case, using that effective is product over sum. Effective is product over sum. Our effective resistance, therefore, will be equal to 4 times 4 over 4 plus 4, and this will give us 16 over 8, which will give us 2 ohms. We can therefore say that the effective resistance here will be 2 ohms. Ladies and gentlemen, this concept again will help you to try out simple circuit numbers. Next time we meet, we shall look at circuit calculations where we shall use Ohm's formula. Ohm's formula is that the PD is equal to the current times the resistance, and that will give us an opportunity to try out numbers that actually require us to calculate resistance. To try out this, try out numbers in your free time. Try out these numbers. Find the effective resistance is the common question. Find the effective resistance. First circuit diagram has this. You have 3 resistors, and these resistors are connected in that format. You have 3 resistors of 6 ohm, 3 ohm, and 2 ohm. The next number, you want the effective resistance. You have 3 ohms, and this 3 ohm is joined with 2 other resistors in this kind of circuit diagram, and that is 3 ohm, yes, and then we have 6 ohm and 2 ohms. And also we have another diagram where we have a 6 ohm resistor here joined together with another pair of resistors of 2 ohm joined together with another 3 ohm resistor. They are asking you to find the effective resistance. You can try out these numbers, and lastly, you can have another set of resistors, and these ones joined together with another pair here, and a combination joined with another resistor here, and we can have a 2 ohm resistor, a 3 ohm resistor, and a 4 ohm resistor joined with a 1.5 ohm resistor. 1.5. I want to interest you to try out those numbers basing on a few techniques we have looked at. I'm sure you will not regret. As I said, when we meet next time, we shall use Ohm's formula, V is equal to I times R, to determine current after getting the effective resistance. God bless you. Have a